Here we go, a little review of the zero product property. There's no video from yesterday, so kids that missed yesterday can watch this part to catch up on that. And it's good practice for you too. The zero product property says, it's got the word zero in it. It's got the word product in it. And product means multiplying. And zero is kind of the whole point of this thing, is you want to make it equal to zero. All right, so this is a typical problem that's been set up for using ZPP. It's got the little product. See how I put a multiply dot in there? And if either this part or this part is equal to zero, then you'll do what? You'll make the whole equation equal zero. Well, here's the thing I wanted to make sure you understood. Why are we doing this? We're setting y equal to zero, and that's the reason we want these to equal zero. But here's a saying that I told you like 100 times. Hopefully it's been ingrained into your brain. That the y-intercept is where what? X equals zero. And the x-intercept is where what? Y equals zero. So I just put a zero on top of y. Why? Because I want the x-intercepts. That's the point of this. We're trying to find the x-intercepts. So we always set the y's equal to zero. I'm going to go put zeros over the top of all my y's because I want this equation to equal zero. All right, so now either this part can make a zero, because zero times anything else over here would still make zero, or this part can equal zero. And so typical answer is just x equals -3 makes that first part 0, and x equals 5 makes the other part 0. So are both answers right, or is it one or the other, or is it both? It's both. And why is it both? Because take a look at this parabola I've got at the bottom here. This parabola I've got set up to have 3 and 5 be my roots. That's different than -3 and 5 that you see in this first problem here. But if I move my parabola like over here, 6 and 8 are my roots. They're the two places that the parabola touches. There's only 3 things that can happen when you have a parabola. It can either touch the x-intercept twice, like this, and most of your problems will, or it can touch it once, like that, or what? Or not touch it at all, and that means it's like up here somewhere. And that means that if it has roots, the roots are imaginary. The roots are not something you can see on the graph. If it touches here, I know the root is 6. In fact, it's a double root of 6. You'll understand more about that in a minute. And if I make it touch here, the roots are 5 and 7. But if it goes like this, it's probably got 2 roots, but they're imaginary. And you'll understand that better once we get into the quadratic formula, why those roots are imaginary. Okay, so now back to what I expect you to know how to do. I'd like you to do B right now. That should be like a no-brainer. And do you have to show any work for that? No, those are so easy. That's so easy that I don't expect to see work. I didn't show you work when I did it. Then do C, and do show me some work, because it's not quite as easy. And then do D. I'll pause while you do that. Bring it again. For this one, it was a no-brainer. But for this one, I need 2 equations. Can you tell me the first equation I could write for this little 3x thing? Yeah. Nope. 3x has to equal 0. And the other equation would be?
X equals 5/4.
You're jumping to the end. Tell me the equation that you'd write in the first place. 4x minus 5 equals 0. And then what do? Add 5 to both sides, and I'd have 4x equals 5. And then what do? Divide by 4 on both sides. X equals 5/4. Over here, divide by 3, divide by 3. X equals 0 divided by 3. There's 2 ways to have a 0. There's either a 0 in the numerator or a 0 in the denominator. One of them is a problem. one of them is okay. Is this one the one that's okay or the one that's a problem? A lot of kids don't remember this one. Okay, good. Glad we're talking about it. Let's talk about 0 over 3. Is 0 over 3 possible? That's the one we have now. And or is that possible? One of these two is possible and one of them is not possible. Which one do you think is impossible? True. Yes, this is the one that's impossible. You could call it undefined. All right, and so that means that this one is possible, and so what's the answer to it? 0. All right, well, let's talk about why. If you have no cookies, you have 0 cookies, and you divide it amongst your 3 friends, they're all going to get a fair amount. What are they going to get? 0. But this is like having 3 cookies and dividing it amongst 0 people. That just doesn't make sense, does it? All right, so now back to where we were on this page. This one equals 0. I have 2 answers. That means there's 2 roots, which means what about the graph? It's a parabola that has what? 2, what are these things called? Roots, which are also called x-intercepts, which are also called, what's the title of the whole thing? Zeros. They're roots, they're zeros, and they're x-intercepts. Okay? That's the main key that you're supposed to have learned. All right, this last one. If you solve this, you might just think that the answer is x equals -3. But I want you to stretch your mind just a minute. You see how there's actually 2 answers? X equals -3 and x equals -3. It happens twice. That means it's a double root. That means you have 2 of them. Well, when you look at the graph, you've got a double root. It's because the graph is bouncing like this. Think of it as a ball being dropped on the floor and it bounces back up. The spot where it bounces, that's a double root. And you'll learn more about that as we get into polynomials. All right. So that's yesterday's stuff. Any questions about that? I feel like you get that. Raise your hand if you feel like you understand that stuff. Okay, good. Now we can move on to the next step. Okay, so now to begin the new stuff. You've seen vertex form before. You've seen general form before. That's generally, you just multiply those numbers together and you multiply out your equation and you'll have general form. Factored form is the new one for today. All right, so let's look at this parabola that we have graphed. The vertex form, sounds like I might need to know the vertex. Look at the graph. What's the vertex? 3, -1. So if I give you that, then you should be able to write vertex form really easy. I'll give you a start. It always starts like that. Okay, on your scratch paper, please write it down. Now the only place to really mess up on this, usually, people put a 3 there, they usually know it goes there, and then a -1 there, and then here, should it be a plus or should it be a minus in between? It should be a minus, okay, because it's counterintuitive. It's not a +3, it's a -3. All right, so there's your vertex form. You remember that? Okay, now how about general form? Generally, you just multiply it out. So go ahead, multiply that out. You multiply it out and then you add the 1, or sorry, subtract the 1 at the end. And we'll finish this up on part 2 of the recording.